Okay, this is day one, actually technically day two of the midterm review, which by the way is the final for trig, which by the way is the big trig final. Awesome. Okay, so let's take a look at number two here. If I have a right triangle here, and I'm going to label it A and then C and then B, and they give you that this is 90 degrees and they give you that this is 54 degrees. It tells you solve the triangle for all the missing parts. Now, on the final or the midterm or both, you're going to need also a calculator. All right, because there's going to be some law of sines problems on there. You're going to have to be taking some inverse trig functions. You will need a calculator for the quiz. So just putting it out there right now. It says solve the triangle for all missing parts, which means you need to tell me what all the missing angles are, and you need to tell me what all the missing sides are. Well, this is B, and this is A right here, and this is 12. So it seems as though I have to solve for angle A, I have to solve for side A, and I have to solve for side B. Does that make sense, everyone? I end up having to solve for those three parts. Okay, angle A is the easiest part because that is 54 plus 90, right? We got a 54 here and a 90 here, and that equals 144. I subtract 180 from that, or rather, that answer from 180, and I get 36. So does it make sense that angle A is 36 degrees? Yes? Okay, sweet. So from here, once we do that, we can do a number of things. If you guys want to revert to using law of sines, that's all good. But remember, law of sines is typically for non-right triangles. So if you want to just use some standard trig, then it's all good. So let's say we try to solve for angle A first, or rather side A. If I want to go from the perspective of angle A, then what I do is I look at side A and I say, look, I've got an opposite, I've got a hypotenuse, that's known, right? I don't know B, so I can't use opposite and adjacent, but I have an opposite and a hypotenuse. So what I'm going to do is I'm going to take the sine of angle A, because sine is opposite over hypotenuse. So sine of A is really sine of 36 degrees. And that's going to equal opposite, which is A over 12. From here, I'm just going to solve for side A by multiplying 12 on both sides. So I get 12 sine 36 equals A. Punch that into your calculator. So sine 36. I'm sorry, make sure your calculator, unlike this one, is in degrees, because that's what we're dealing with right now. And I will always differentiate for you which ones you're going to solve for. So sine 36 is 0.58, and then times 12, right? Okay, so it looks like side A is going to be 7.05. All right. And then we're going to go ahead and solve for side B. So if I solve for side B, if I look from the perspective of angle B, then it's going to be opposite over hypotenuse again. So that's, again, sine. I missed something here. Oh, here we go. Okay, so now this is going to be sine of 54 is equal to B over 12. I multiply both sides by 12. So I get 12 sine 54 equals B. Did I miss something, Chris? That's law of sines. Yes, you can do that. Yeah, Chris. Max. Because I'm trying to get B by itself. I'm trying to get B by itself. So now I have sine 54 times 12. So I get 9.71 about. And that's all you need to do for these problems right here. Boom, you're done. Okay? Michael, what's up, buddy? Can't hear you. It is not only recommended, it's necessary. Yeah. Yeah, you have to have one. Otherwise, you're not going to be able to do the law of cosine problems and law of sines problems. Okay. All right, it says here, numbers 7 through 10, find the value of all 6 trigonometric functions. Let me see here. If theta equals 5 pi over 4. Let's see here. So we do number 9. Okay. Theta equals 5 pi over 4. Okay. You have to draw from the unit circle on this one. So at 5 pi over 4, what you're going to be asked is to find sine of theta, cosine of theta, and tangent of theta. So at 5 pi over 4 radians, what is sine? Well, 5 pi over 4 is in quadrant what? 3. So it looks like it's going to be around me see here, right here. Am I going crazy right now? Like, yeah, sorry. I'm still in debate mode. Sorry. Okay, 5 pi over 4 is right here, right? It's the 45-degree angle in that area. Sorry. Okay, so now what's sine of 5 pi over 4 in this particular quadrant here? Teacher Joseph? It's negative rad 2 over 2. Cosine is going to be the same, and then tangent is going to be 1. And then from here, to find the other three, you flip them, right? So cosecant of theta is going to be negative 2 over rad 2. Secant theta is going to be negative 2 over rad 2, and then cotangent is still going to be 1. Okay? If I asked you guys to rationalize the denominators, here's what they would look like. So it would be negative 2 rad 2 over 2 for both. Okay? So that would be how to do problems 7 through 10. Let's move on. Number 15. Oh, I'm sorry. Just kidding. Suppose theta is an acute angle if a right angle. Okay, find the remaining. Okay, so I have no idea what that's saying. I think there's some missing instructions there. Okay, it says sine of theta equals 2 over 3. Okay, so if we do number 11 here, if sine of theta equals 2 over 3, what they're asking you to do is they're asking you now, it's just like numbers 1 through 6, except they're asking you to draw the triangle out. So if I go ahead and label this thing out, they say assuming C, I think they mean assuming C is the right angle. So C, let's call this A and let's call this B. So C is going to be the right angle. Now sine of theta is going to be 2/3. Now theta can be any angle I want. Do you want to make it A or do you want to make it B? Chief, what do you think? A? Sure. Okay, so if sine is 2 over 3, then it's going to be opposite over hypotenuse. And now we get to use the Pythagorean theorem to figure out the other side. So 2 squared plus B squared equals 3 squared. That's 4 plus B squared equals 9. B equals rad 5. Okay, so that's how you do that part. And now we're supposed to solve for everything else. So it says find all remaining trig functions of theta. Okay, so we have sine theta, which we already found. We have cosine theta, which we need to find. Tan theta, and then cosecant, secant, and then cotangent. Okay, so now what we have here is 2/3. That was given to us. Cosine is going to be adjacent over hypotenuse, so that's rad 5 over 3. Tangent is going to be opposite over adjacent, so 2 over rad 5. If I wanted to rationalize it, it would be 2 rad 5 over 5. And then everything else is flipped upside down, so 3 over 2, 3 over rad 5, and then let's call this rad 5 over 2. This would be 3 rad 5 over 5, if I wanted to rationalize. Are we good with that? Just draw a triangle. Don't be like Tim Westwood. I saw him a few days ago, actually. Okay, so now, what are we on, 15? Solve for the following right triangles. Okay, so 15 through 18, it's kind of the same thing, right? So we've got, if I do number, say, 16, assuming C is a right angle, so if I call this A and I call this B, so then I get, what are we on, 16? So A is 35, and small a is 7. Remember, the lowercase letters are always opposite their corresponding angle. That's why lowercase a is always opposite of uppercase a. So now, raise your hands if you actually need me to do this problem. Or raise your hands if you think you can do this one on your own. Do this one on your own? Okay, cool. You're just doing the same thing as we did before, right? You're just doing all that. Okay, cool. So goodbye. All right. So now, my favorite. Convert each degree measure into radians. So let's look at number 21. Random problem here. Negative 80. I'm going to write out the words. Okay? Negative 80 degrees. Now, I'm trying to convert that into radians. So I'm going to say pi radians over how many degrees is in pi radians? 180 degrees. Now, remember the thing that pisses me off. The words cancel each other out. I don't know why that makes me so mad, but it does. See, that's going to go away with that. 18 divided by 8. Let's see, they both go into what? 2? 9. And this becomes 4. So, looks like negative 4 pi over 9 radians. Okay? Nate, what's up, buddy? Over 360? Oh, because you don't need to. You just reduce the fraction. If you go 2 pi over 360, you can just reduce and make it pi over 180. It's just smaller, easier to deal with. But you can use 2 pi over 360 if you really, really want to. I mean, you could really use 4 pi over 720 if you really wanted to, but, just keep it as simple as possible. Okay, so next, let's do number 24. Changing radians into degrees. So I'll call this rads up here. Times. It's the opposite, because you want the words to cancel each other out, because the words are going to be on bottom. So this is pi radians over 180 degrees. The radians cancel each other out. The pi's cancel each other out. Darn it. What do they both divide into? 8? No. They both divide into 2. So you get a 4 down here and a 90 up here. So you get 270 over 4 degrees. Is that dividing evenly? Nope. Or 67.5 degrees. But leave it like this. I am happy with that. Okay. Hey, 29 through 38, that's just from the unit circle. You better know how to do that. Okay, 39. This is actually an old formula from geometry. The area of a triangle is equal to 1/2 base times height, but sometimes you're not always given that. So in trigonometry, we use 1/2 what we call BC times sine of A. Now, B and C are just kind of general sides. It doesn't have to be B and C. Angle A doesn't have to be the one that's found. It's just 1/2 BC times sine A. So 1/2 one side times the other side times sine of the angle that they gave to you. So that's all it is. 39 is A equals 11, B equals 13, and angle C equals 31 degrees. So in order for me to use this formula, I'm going to say the area is equal to 1/2 BC, or in this case, the two sides that they were given, in this case it would be AB, times sine of 31. From there, you punch it into your calculator. So you take sine of 31 times 11 times 13 divided by 2. Your area should equal 36.83 units. Does calculator work? Dustin, what's up, buddy? Okay, again, this is not locked in motion. Okay? It's just 1/2 times the two sides that they give you times the angle that they give you. Does that make sense, dude? Right? Yeah, so again, it's not definitively sine A. It's just sine of the angle, whatever that angle is. Yeah. Okay, Dustin, good question also. Okay. Using the law of sines, determine the number of solutions. Good question. Okay. Let's take a look at number 43 here. What's the order of like the things that they gave to us? What did they give to us? An angle and two sides. So, when you have an angle and two sides, how many triangles do you potentially have? 2 of them. So, let's go ahead and draw one of them out. This is 65, this is 6, this is 8, whoops, this is 6 up here. Okay, so now let's go ahead and use the law of sines and figure out this triangle here. So this is going to be, ooh, man, I've been moving down a lot. Okay, okay, so we've got sine 65 over 6 is equal to sine of B over 8. Cross multiply, I get 8 sine 65 over 6 is equal to sine B. Okay, let's do this in our calculator here. So 8 sine 65 divided by 6. Oh, Awesome. This is really cool. Oops. Why is that such an awesome answer? Why do I love this answer right now? Anybody know? Guys, do inverse sine of that value. Cameron? 1.208. But actually it doesn't really matter because try inverse sine. Yeah, it doesn't work. This is no solution. That's awesome. Okay. How do I know that? How do I know that? Because inverse sine of this value produces no solution. So there are no triangles that can be produced by this. Because I'm solving for an angle, I'm trying to solve for I'm trying to solve for angle B. Max and then Nate. Because that's the law of sines. You guys need to remember that formula. Nate. I did, and then I divided it. Okay, let's do the law of cosines. Say again? Oh, law of cosines? Yeah. So it'd be a squared equals b squared plus c squared minus 2bc. Oops, not sine. Cosine. Cosine A. The other variation is b squared equals a squared plus c squared minus 2ac cosine b, and then c squared equals a squared plus b squared minus 2ab cosine c. Sorry, I was coming off of a debate tournament, so oops, had to be a little slower. Okay, so let's go ahead and take a look at number 45. They give us a, oops, capital A, equals 51 degrees, B equals 40, C equals 45. So now we have to solve the triangle, so we have to solve for everything. Let's see here. Let's go ahead and try and find side A first. So that's, if we try to solve for side A, okay, I'm sorry. You know, let me change colors here. Since they give us this information here, does it make sense that we need to solve for side A? We need to solve for angle B, and we need to solve for angle C? Does that make sense? Those are the things that we're trying to solve for, okay? So now let's try and solve for side A. That's going to be a squared equals b squared plus c squared, so 40 squared plus 45 squared minus 40 times 45. Big numbers. 2bc cosine of angle A, so cosine 51. Okay, so 40 squared, 1600, plus 45 squared, 2025, minus, see, 80 times 45, 3600, cosine 51. Okay, so we got 1600 plus 2025, so that's going to be 3625 minus 3600 cosine 51. What is the biggest mistake that I see people make right now, Max? They're going to try and combine these two. You can't do that. You have to use order of operations. So you have to do 3600 times cosine 51 first. That is 265.55, and then 3625 minus that answer. So what you get is you get a squared equals 1359.45, and then you take the square root of it to get 36.87 units, whatever that is. Now, you have to find the other pieces also. See what that looks like. Let's see here. If I want to solve for angle B, then it's going to be b squared, so 40 squared is equal to a squared. We found 36.7, or 36.87. squared plus c squared, which is 45 squared, minus 2 36.87 times, what do you call it? C, 45? And then cosine of b. Okay, so this was 2025, and then this is 1600. So now I have to figure out 36.87 squared. I got 1359. Just kidding. No, I didn't. 36.87. Oh yeah, I do. I get 13. My bad. 1359.40 plus that minus 2 times 36.87 times 45 minus 3318.3 cosine b. Okay, now let's see here. So we're going to do 1359.4 plus 2025. That gives us, this whole thing gives us 3384.40 minus 3318.3 cosine b. And then I have that all equal 1600. Now again, don't combine them. You're going to have to subtract 3384 from both sides. So 1600 minus answer is equal to negative 1784.4 equals negative 3318.3 cosine b. Now divide that by negative 3318.3. You should end up with positive 0.5377 is approximately equal to cosine b. From here, because you're solving for an angle, you take inverse cosine of both sides. So b, after all that work, is equal to 57.47. To find angle C, what do? Add them up, subtract that from 180. So plus 51, and then 180 minus answer, 71.53. There you go, people. There's some work for you. Yeah. Uh-huh. Because you have to get a by itself. A is being squared. Okay. 48 through 50, it's the same problem using law of cosines. So we won't do that. I won't waste your time. Okay. Let's take a look at something like 51. Okay, the length of a ski lift. Refer to the figure. So I'll draw the figure out for you guys here. Crap. That's 15 degrees. This is 25 degrees. And the rest is nothing. Sorry, this is 1,000 feet. Awesome. Okay, so it says a proposal is made to build a ski lift from A to B. To find the length of the lift, the surveyor measures angle DAB to be 25 degrees. He then walks it 1,000 feet from A to C. He measures the angle ACB to be 15 degrees. What is the length of A to B? So we're trying to find the length of the dotted line here. So I'll go ahead and amplify the dotted line by putting it in green. Not that helps. Okay, so now we have to figure out what the length of side AB is. Now, this 25 degrees here means something because from there we're able to find the measure of angle A. So angle A is 180 minus 25. So that is 155. Okay, 155 degrees. We have angle C is equal to 15 degrees. We have side B is equal to 1,000. We have enough information to run law of sines on this thing, I think. Oh, no, we don't, because we need to figure out what angle B is. How do I figure out angle B? We take the first two, and then we subtract from 180, right? So 155 plus 15, that's 170. So B has to be 10 degrees. So now I can use law of sines and say sine of 10 over 1,000 is equal to sine of 15 over looks like AB. Right? AB is the green line. Yes, are we okay with that? Max, you okay with that? Okay, so now we just cross multiply. So I get AB sine 10 equals 1,000 sine 15. Divide by sine 10, and you will have your answer. So let's take a look. Sine 15 times 1,000 divided by sine 10. I got AB approximately equals 1490.48. Looks like feet. Of course we use the law signs, yes. Easiest one. Okay. Ooh, the height of the plane problem. That's kind of gnarly. All right. Let's take a quick little break, and then I'll get you guys back.